Welcome to our 17th episode of the Water Talks podcast, where water science, innovation, and application receive the focus they deserve. I am your host, Vanbeckevoort, and I am delighted to be joined by my co-host, Scott Bowron. Hi, Scott. Nice to see you again in this new year.
Yes, good morning, Els, and a little late in the season, but Happy New Year's. We haven't really chatted. You've been away, and business is booming. So nice to be back
Indeed.
together.
Nice to see you. Yeah, for sure.
And today we're changing the look of our program today. We're introducing a video into the talk today. It's pre-recorded and based off of the design considerations from a European perspective, and it was based off a visit that Els did while in the Netherlands. It's the largest facility in Western Europe. And then Els took that information and had a discussion with her colleagues in Holland in early January, and that this is the end point of that. And after the tour and the existing of the facility, discussed the design of the 7 new pools. This is a monster facility. Added both a competitive and a training perspective to it. And for the benefit of our listeners, we're going to introduce with slides, and then we're going to go to the video perspective.
Thanks. Yeah, Scott, it was quite the visit and interesting for sure. But for our listeners, please do remember that the pool design and water treatment considerations discussed in our episode are best for that specific location. So multiple options do exist for new pool design and retrofits for existing facilities that perhaps can borrow some of the best practices or the lessons learned, right? So there are lots of other methods for water treatment that can also help manage site-specific requirements, and limitations can sometimes be improved based on, any mistakes that people have made in the past, and they're learning from that. So really our goal today is to provide some visibility to our listeners, looking at the state-of-the-art facility, and it was quite impressive, and some very useful takeaways potentially. So this is for our pool engineers or architects, equipment suppliers, builders, and operators. And I also want to sincerely thank the National Swim Center, the Tongelreep in the Netherlands, for a great tour and permission to share a couple of images, and our esteemed colleagues from Labrador Van Sem, who we'll be introducing shortly as well. And we'll look at some slides together. So I'm going to just share my screen, and for the listeners who are not actually watching this, we will describe what's on there. And we'll go from there. So our title is Pool Design Considerations, Lessons Learned from the Netherlands. And I think, Scott, you're going to take it away for us now. So we'll start maybe at the beginning.
So as Els mentioned, every pool will be slightly different. What's the needs of the pool? And so we're going to bring you through some of the slides we've used in previous talks, and just bring that to the current. And then Els is going to take you through some of the slides of the actual facilities. All right. So we always start with the idea of a system of systems. So what does that mean? And everybody is a relationship. And that, to me, this is the nicest slide you'll ever see to really understand the staff. What are people doing? Why are you building the pool? And everybody in the facility has a part to play, and it has to be understood because they're interlocked. And so this gives you a perspective of where you are and who's involved in actually making the system, building it correctly, and then maintaining it correctly.
Exactly. Yeah. The aquatic center is quite complicated, right, Scott? Like there are lots of moving parts. And so understanding that, those are all important, whether it's a mechanical system or the water system or the chemical system or electrical or regulatory or the building itself, the staff, or the regulators or the guests, like everybody is connected, like Scott said. And I think it's really valuable to understand it like that, at the kind of the beginning as we talk about pool design considerations.
It's actually awesome, Els, because I was just on a call with a customer this morning with a Teams meeting, and we just had this discussion with all the different groups, bringing it together for the shutdown, and you realize the silos that people live in, and trying to bring that together. So it's a perfect slide.
Excellent.
So you always start with the end in mind. What do we want this pool to look like? what are we going to use it for? So what's the occupancy? When will we use? What's the programming? Programming has changed over the years. How we used to build pools 40 years ago has changed. Who uses it? When they use it? What's the desired outcome of that? And then water and quality, air quality goals. People come to a pool to be healthy, and we always have to keep that in mind. So we can't just build what we always built. We
Right.
have to build it to today. And the sustainability, we're talking green energy. It's such a big, huge part of our world. Pools love heat and love energy, and we have to understand that and accommodate it. And building a good pool that's healthy and sustainable is possible with
Right.
good endpoint inside. And then the building other uses. If you're building a multiplex, there's going to be implications related to that. Source water, we always talk about as a good water chemistry, understanding your source water. Where does the water come from? It's different in every facility and every location that you're in. Else, this particular facility we're talking about is in Europe.
Right.
So the water chemistry is going to be different than even the next town. And then
Exactly.
regulatory framework, we're dealing with probably the strictest water chemistry guidelines in the world. I
Yeah.
don't think that's an outrageous statement.
No.
Uh, and they make it work.
Right.
And how do they make it work? Through good understanding. So that's really where we're heading.
Yeah, no, exactly. And I think, having kind of all of those things in a conversation at the front end is going to be extremely helpful, right? Whether you're building a new pool or you're upgrading your old pool, like having some good goals in mind is going to be very helpful as well. So maybe Scott, walk us through, healthy water, because Sneakotech has been talking about it, and we've been talking about it for a long time. What does that mean to go beyond compliance?
Right. So we're put it into four quadrants. Microbiology is obviously understanding it, first of all, and then dealing with it. Optimizing your disinfection and your source water will end up being not only a better experience, but financially, air quality, the mechanical systems, all the implications of all that. One thing leads to another. A healthy pool, do people even know that when they go home and 2 hours later they don't feel well, right? What is that caused by? So we want to make sure that we as operations staff have the tools on build to deal with airborne toxins and free from anything that's in the pool that will make people unwell. And then aesthetically pleasant. Uh, do people know when they walk into a pool they shouldn't smell that pool, that it should
Right.
be odorless, that it colorless, that the water clarity is sparkling,
Yeah,
clear, crystal clear blue? That's always the words I use, right? Those are the things that we as humans like to see when we deal with water, like going to the
exactly.
Caribbean. And then the sustainability part, which historically hasn't been discussed in the pool world. We just make them run, but they are energy. They use a lot of energy. Heat energy is a big cost factor. So how
Right.
do we reduce the chemical usage, make it compatible with the infrastructure, and then compatible with life? So long term, you bring people in, you want them to be healthy and healthy for a lifetime. And Els is a swimmer, so really has a big uh,
Appreciation for sure.
appreciation for good water, and for those of us in the industry, understanding that is so important.
Yeah, no, absolutely. And I think, taking all of those integrative approaches to it, it will help us as well to actually, economically come out on top, right? So that's kind of the interesting thing in all of this, that, people would say, okay, yeah, we want all of this, but, what's it going to cost? Well,
Right.
generally speaking, you save resources. From an operational cost perspective, significant waste reduction always leads to reduced cost. And, that's a wonderful story to tell as well. So then I'm going to just briefly walk you through, what this facility is all about. And like I mentioned early on, this is, specific and unique to this one. But as Scott also mentioned, the regulations in the Netherlands are the strictest at the moment in Europe. And so they've been around for about 12 months now. And some of those considerations, of course, are part of how they try to approach everything in how this system was designed. And Holland is quite progressive also in terms of their water management, have been for many years a market leader in lots of different ways, not just in the pool world, but also in municipal drinking water applications on the waste side, being a very highly populated, densely populated country, and also having to deal with natural resources in a very sustainable way. There are lots of those things that really come to the forefront as we look at what kind of the approach has been. So very briefly, it's an existing stadium that they have added additional pools to. So this pool that you're looking at, they're currently doing some retrofitting, some retiling, some maintenance on. This is the swimming stadium that basically has this 50-meter competition pool, seats about 2,500 people. It's where the Dutch national team often trains as well. It's used for a lot of competition purposes, and so it's a state-of-the-art facility that already has been around since 2008. So what we're looking at here is kind of the legacy part of the complex, same as the dive pool. So all of it is concrete construction, tiled, and what I mean by floor injection really is that the return water coming back to the pool is coming into the pool through the bottom, and basically then dispersing that way. So that's in general is the preferred method for return water, although some pool designs don't allow for it, and we'll talk about that briefly after. This is their newest 15-meter competition pool that was opened in, I think, early November last year, so not been open very long. Some very interesting things. So coming into this pool, there was a couple of things that I, as a swimmer, immediately noticed. One was the acoustics. It was very pleasant. There were a bunch of people. You don't see it here in this slide, but a bunch of people on one side of the pool, like they were hollering and jumping and having fun and doing some trading. And it wasn't noisy at all. So that was the first thing that I noticed as I walked in. The second thing was there was no smell on deck, like at all. And, we are trying to help our Canadian clients. Scott and I have been working, tirelessly to help that, that same result be achieved here. But it was very compelling. The second thing, or the third thing rather, I noticed is that it was all wood. And there lots of wood paneling, like everywhere. And so as I was asking some questions to one of the senior technical people, they basically identified the fact that this is triple glazing. There is no stainless steel above the water at all. So no corrosion risk. All of the LED lighting were dimmable as well. So it was a very pleasant environment to swim in. And then from a sustainability perspective, they had triple glazing, solar panels on the roof, an energy rating that was almost at net zero. So 6 months of the year, it's at net zero. And that's really quite something. So lots of heat recovery, which we'll touch on briefly after, and water temperature about 27.5 Celsius, and air temperature, a good degree and a bit above. And so that's incredibly helpful, and so that was a very good first impression coming there. The LED dimmable lighting with optimal acoustics I've already touched on. So here you can take a closer look and see how the lights actually work really, really well. So they don't shine in your eyes as you're swimming. It's a very comfortable environment as well. As I mentioned earlier, floor injection or floor returns in all of the pools, actually, all the 7 new pools, except for one pool that has a movable floor pool that basically has this side return. But as a rule, they all have this kind of or similar return coming back to the pool. One of the really useful and interesting things that I thought was just ingenious, and I think everybody should be taking notice of this and learning from this, is the floor drain. This is the pool deck waste drain, so not the floor drain from the pool, but the actual waste drain on the deck. And if you look at it, it's quite far from the side of the pool, and it obviously drains downhill. So when they're doing cleaning around this pool, there is no risk or very little risk of that water ending up in the pool. And you'll hear this in the videos we're discussing this, but generally speaking, it has led to serious contamination issues in the pool water because there's generally high organic load. And so avoiding that is a really helpful tool, and I think a really good one for us to potentially learn from here as well.
That's a great ad. Els, using the trench drains.
I
So
know. I
get that
know. Yeah,
And when we did that chat uh, with Gerben before, the discussion on organic load on pool deck is
crazy. I
it
know.
things we just don't even know, right?
No, and
So
we're not testing for it. Whereas in Europe, there would be regular testing, and so you'd know what lives there. But it is a really a good way to deal with this proactively.
look too. So from an architectural perspective, you don't
Yeah,
even notice it. The customer doesn't know it,
yeah.
but it's a lot of value.
It adds a tremendous amount of value, and the operational technical staff also mentioned this. This has been really, really great. This is the therapy pool. I just thought it was a cool picture. Obviously, you can see the floor drain, or the floor drain rather. The floor return rather is a little bit different in terms of design. It's got some cool lighting. They're running it at 32 Celsius and air temperature at 33. The other interesting thing is where we would build a pool with multiple pools in one large space. None of them had none of them were like that. So every pool had its own unique space, and like it's right beside the 50-meter competition pool that we just looked at, but it's all closed off so that the water air temperature ratio can be respected correctly. And I didn't even have to bring it up, but they were telling me no, everywhere, every single pool has the correct correlation between water temperature and air temperature. It is the most important significant factor for them to manage their energy efficiency for those systems. And so it was interesting to see that even in this space, it didn't feel particularly muggy because the humidity was actually, it was warm in this pool area, but it wasn't muggy at all, and they were respecting the same air water temperature differential as well.
Nice.
This is the new complex that's yet to come. It's going to be opened in March, but I just thought it was interesting to take some pictures of, they've gone for a very different design here, not the traditional blue, but more earthy tones. And it's going to be it's got a lazy river. It has a number of different features that is going to be interesting. 3 slides, an activity pool, quite a large activity pool here. So this is all coming, but is yet to follow in a few months' time. So we got to see again all the same principles that I've just talked about were there as well. So here is just a quick view. I mean, it's a huge space. Underneath this whole complex is the same size as above deck as below deck, and they did that intentionally. So you can actually physically walk around every pool underneath. And that makes it very, very serviceable and easy to do the things that you need to do. Now, for this facility, they have chosen ECA. So basically, they're using electrolysis for generating chlorine on site. Now, the interesting thing about that, of course, is that you're making the good species of the chlorine, and we can't get into it today, but that basically provides very good disinfection, and it has an interesting byproduct as well, which is sodium hydroxide, which is then the other aspect that they're using. So they're using the waste for pH control, and so it's a very efficient system. So they have one large ECA chlorine generating system that basically generates fresh chlorine every day, all day long for all of the different pools, and then that basically goes out to to the individual dosing systems and control systems as well. In this particular situation, they're using multimedia filtration and using polyaluminum chloride flocculation and lots of heat recovery. So they're using heat recovery on the incoming water. So the city water coming in, they're taking heat from it. And all of the water coming from the showers or the wastewater, they're also taking heat from it. And this is, part of their sustainability approach. In getting to that 4+ rating, where 5 is net zero, they're at 4+, because some of the months of the year, like in the winter time, they're not at net zero. But it's quite something looking at how their heat recovery is working. Now they're using natural gas and they're using heat pumps and they're using both. And that's interesting because here some pool facilities are using heat pumps only and are struggling in the winter. And that's interesting to me because Canada has more challenges from a temperature differential perspective than the Netherlands does. And so having that backup of some natural gas seems to be critical. So something for us to consider here as well. Um,
So I
yeah,
have a
go
question
ahead.
for you here. One is the temperature that this location is. Is it similar or warmer than our general Canadian temps?
Well, Holland is a more mild climate, I guess. So the summers are cooler than us, and the winters are not quite as cold as us. Like it's not like they will have frost days as well, but
Vancouver,
maybe not deep frost the way we do. Sorry, go ahead.
Vancouver type
The,
temperature. Van-
yeah, maybe West Coast or East Coast, perhaps. Although East Coast can get a little bit brutal as well. Yeah, maybe not quite as temperate as the West Coast, but kind of similar. Yes.
and the other question I have is, does Europe follow leads at all? Like, is that when you sing 4+to 5, is that's the same kind of idea?
It is. It is. So that's a North American standard, but it's very similar. So where F is a like a completely inefficient system, and 5 is net zero, you have F 1, 2, 3, 4, 5, and then the plus is kind of okay. That's kind of the next level within that range. So their status is 4+, and that takes into consideration that half of the year they're at 5, and then some of the months they're around 4+. And that's basically as I mean, from my perspective, I don't think I've yet, and that's from an operational perspective as well. So we talk a lot about energy efficient buildings, and that's a good thing. But they're talking about their energy footprint, the operational energy and water, and the energy footprint on a day-to-day basis. And I think that that's a really compelling and interesting story, because from my perspective, I don't think yet I've come across a swimming pool that that has that kind of rating. But yes, it's very similar to what we would do with a lead standard here.
Right. Just
Yeah.
so everybody understands what you're
For
talking
sure.
about.
For
Yeah.
sure. And all of the pools are monitored and controlled using photometric, colorimetric principles to ensure, because I didn't mention this, but all pools are run at zero point 0.8 parts per million. Even the therapy pool, the higher temperature pools, everything is run at zero point 0.8 ppm. And so they need to have a very tight pH, 7.3. And they told me that's what they run at. And I'm like, okay. And how much fluctuation? Oh, no fluctuation allowed. 7.3. And then obviously they're running at zero point 0.8 for free chlorine. And that's across the board. And that also helps them to meet all of their health and safety criteria from the regulatory perspective. That's an example of a multimedia filter. They're concrete built in place filters. They all have a big light so you can actually see the water column inside, which is really useful as you're trying to, find out what's going on inside the filter system. But that's just an example. The other cool thing, and I think we're almost at the end of our slides here, is they had some interesting process monitoring and control sample locations. So you can see here, it's right by the ladder, actually. And, they move these to a place where they would consider to have low flow, right? So where you have return lines coming in. Now, this particular pool had a movable floor. So all the returns were on the side. So side injection, we would call that. Anyways, and so here was both, this is an intake for the monitoring, and this is an intake for the control, and they're not the same line. So this pool complex has the permission by the regulatory body to do automatic monitoring. So every 30 minutes, every pool is monitored, not just for free chlorine and pH, but also for combined chlorine and total chlorine, combined chlorine, disinfection byproducts, right? So they have no more manual grab samples. And so they have these really cool lines here that are in every single pool. And they go, and I'll show you in a minute where they go to. But anyways, it's quite interesting, and it's quite safe, so nobody can get stuck to these suction these sample lines as well. They have a special system that our colleagues actually designed. It looks something like this, and so if there is any kind of pressure on the system, the pump goes on and equalizes the pressure, and it'll basically start to pull in air so that there's no suction. Anyway, that was kind of a very cool look. And here, very briefly, here's the control system. So as you can see, there's all of these lines. So that's just one section. So that's for can't see how many pools it is. 1, 2, 3, 4, 5, 6. I think maybe 6 or something like that. And then on the other side are all the other pools. But this system, every 30 minutes, it grabs a sample from one of the pools. This is then the control part of it. So this system will also direct, if you like, or interact with the system, but this is doing the controlling, and it's measuring every 5 minutes. So not every 30 minutes. So from a monitoring perspective, they're getting a lot more samples in than what we would do normally on a day-to-day basis, obviously, as we're trying to go around and, we're sampling every 2 hours, Scott, or every 4 hours. I can't remember, but anyway, it's depends on
what your system is, but generally on a big commercial, we recommend every 2 hours.
Right, exactly. So I think that gets me to the end of kind of the overview. But I for our listeners, I want to make sure that they can get a sense for, okay, what does that facility look like, and what does it sound like? What have they built in? What systems, generally speaking, are running? They also have a UV. I didn't really mention that, but they also have a UV system. And UV generally in Europe is used on side stream, and is always using a polychromatic lamp or a medium pressure system, because single phase lamps generally create a lot more disinfection byproducts, and so they also have a little bit of activated carbon that they add to the media just to further enhance the reduction of disinfection byproducts as well. So those are all regulated, and those are all different things that can be done, even adding to existing other good physical filtration systems, just to make sure that we deal with the already formed disinfection byproducts. So those are other useful tips potentially that we could borrow from this. So I think for our listeners, we're gonna now let you guys take a listen to a round table conversation that I had with Ludo Feyen and Christel Broux and Gerben, who are colleagues in the Netherlands that are working together with us from Labo Durva and SEM, and they came on this visit with me to this facility. So we have an interesting conversation, getting their perspective on pool design considerations. So please, hope you enjoy this short conversation, and Scott and I will be back with you shortly to say goodbye. It's great to be back. Thank you for a wonderful day so far. It was nice to have a little tour this morning and have some fun together and go out for lunch. And
yep. I hope you had a nice trip on the new pool here in Eindhoven.
I did. It was actually, it was really cool to see it.
Because the Tongelreep is now officially the biggest pool of Holland.
The biggest pool in Holland.
En ver daarbuiten.
And
far in, like in Europe?
Yeah, and
West-Europa denk ik.
Western Europe. So we went to visit
Als het niet verder is.
a beautiful pool complex that already existed. That was Olympic Training Center, I guess, and like since 2008, Gerben, I think you mentioned.
Yeah.
And then they have expanded it greatly. We had an opportunity to see some of the new pools after commissioning, and they were really impressive. So today, with my good friends back in Europe, we are going to chat a little bit about pool design considerations, and maybe we'll start really large, kind of very kind of big picture, and then we'll kind of start to maybe focus in on a couple of aspects of pool design. So maybe I was really impressed with the way the pool looked. Gerben, you want to talk about that a little bit today? Like, it was just beautiful, huh?
It's a nice pool to see with all the most modern design things inside. So no steel construction, all wooden parts on the ceiling, paneling, ceiling, nice tiles on the ground.
The gutter system,
yeah,
very cool. Explain that, because that was like, I'd never seen something like that.
So the all the surfaces where you can walk around the pool are tiled, and they have a gutter drain in it. So all the dirt, the pool water is nothing of dirt on the panels, on the
Tiles,
tiles is not coming into the swimming pool water.
Yeah, that was really cool. So the gutter is like quite a ways away from the pool, and it all flows kind of downhill, like it's on a slight angle, and that will really avoid a lot of contamination coming back into the pool, which is a major problem. Like, it's actually underestimated. I guess you see that a lot.
A lot of problems in the swimming pool is caused by cleaning water from the tiles, what is coming in the pool.
Yeah, and
it
then
gives also filtration problems.
Okay, and you see that frequently.
Yeah, it's a big cause of problems or problems with parameters in today.
Right, right. Yeah, no, I thought the ceilings looked great. The lighting, the LED lighting was kind of like there was no stainless steel anywhere above that it could look at all.
So all LED lines instead of spots, they're all lines. And they're fully
Looks more
dimmable,
natural.
so they always have the same amount of light in the pool.
It looks really nice. There's no sharp lights that's kind of shining into your eyes when you're swimming, and very nice experience.
And all the acoustic panels are also designed in the ceiling and not separately or mounted afterwards. Special acoustic panels. No, it's already designed in the ceiling.
Yeah. No, I also Simon mentioned that it's a very energy efficient pool built. Like he mentioned that it was just below what we call net zero, but there's lots of heat recovery.
Yeah, and triple
Glazing.
So
Yeah, and heat recovery from the incoming water, heat recovery from the wastewater, heat recovery everywhere.
Yeah.
He also,
Maximum recovering from what we can
what you can do.
go for energy.
Yeah, and he mentioned also that it's anyway, like from an energy perspective, it's obviously doing extremely well, but there's always a little bit of waste. But he mentioned that they're using a heat pump, but also still using natural gas as a backup, and that seems to be the common practice.
That's the common practice.
Yeah. So heat pump alone is challenging. Yeah? It's not always going to work. He mentioned sometimes you need.
Okay, but when the heat pump doesn't work, the rest doesn't work either.
No.
And you need a lot of energy. So if you have a lot of solar energy, then it could work. But in this case, there is a drinking water station beside the Tongelreep, and they use a heat pump system to get warmth of the drinking water.
Right.
They take 3 degrees from the drinking water system with the heat pump and put that in the swimming pool.
Yeah. You mentioned they have a lot of solar panels on the roof as well, like a lot apparently.
Yeah.
So that all helps as well, I guess. So maybe the other thing I noticed was no smell.
No.
I walked around everywhere.
But no smell because we don't have that lot of people in the pool either. Eh?
True.
But I'm sure that there is, on the end, no smell. But you couldn't say today there is no smell because
it wasn't very busy yet.
it was not busy
It's just
enough
been
to
opened,
give that
and
opinion.
yeah. But I know that where it has been busy in the past in the old section of the pool.
Yeah.
I've walked on deck there many times and there's been no smell, so that's been very, very nice.
Yeah.
So maybe let's kind of go back a little bit, and so in order for us to address the water quality and the air quality, we have to address the water quality. So what do we have to consider when we think of design?
The right flow in the pool. So
We've seen a couple of problems, but they have to change that or to
But in an
do something
optimal,
about it. But in general terms,
in an ideal world,
I never had expected that the color what they used for the pools shouldn't be that nice effect. Normally we speak from white and blue, but yet now we had more reds. Zeg het daar, rood-achtig.
earthy tints, pinks and reds, and
I must say it was beautiful to see.
It was very
in
beautiful to see.
the recreation park. It's very luxury with all that mosaic. That's
Very small tile.
1 by 1 centimeter tiles.
Yeah, no, it looks amazing.
It looks amazing.
It's going to be very nice.
The question stays natuurlijk, is something like this making profit or not?
Yeah.
Right.
Now is it in 5 or 10 years?
Right.
It's still as beautiful as that. But
Oh, for sure. But generally speaking, maybe then just finishing with pool design, like construction is all concrete, Gerben? That's
Pools
the
all
most
concrete
common
with tiles.
design for pools,
The only good one.
from your perspective.
Yeah.
And can you explain to our audience, Ludo, why it's, from your perspective, the best one?
Why? Because when you give the construction the time to dry, you cannot have a better construction system.
Okay.
If you don't wait long enough, you have troubles.
Yeah.
Also, if you do what you have to do in pool water treatment, and I'm not going to tell something about aggressivity or not aggressivity, because aggressivity is always there in a swimming pool because of the
course.
chlorination,
Yeah.
so you can't avoid that. But the reaction from the water to the joints is minimized in this situation. First of all, because it was well done.
Yeah.
Second is they took the time to
Yes.
dry.
To dry properly.
And third is, I think the water treatment is mostly perfect, what we can tell us.
Yeah. Yeah. It's as optimal as it could be.
It's better than expected.
Yeah. Okay, so maybe let's maybe contrast that with other pool systems that are also good, but have some of their unique operational challenges.
Yeah, we have to make one remark in the whole situation is this is a pool that costs a lot of money.
Mm-hmm.
So not every company or every community
Every municipality,
is able or has the money to construct a swimming pool in this situation like it was here.
Yeah.
But it was almost perfect, I think.
Yeah.
And let's find out what we see in a couple of years' time. But I think this is ready to go for about 20 to 50 years before having any problem at all.
Major changes or challenges, for sure. And I guess other pool constructions are like stainless steel is another more new, I guess, or more modern construction type, although it's not very common in the Benelux, I guess.
It started somewhere, but it never
took off.
It never had that success what they wanted to have it in the beginning. And the real reason is that you have to good water quality on one side, but you also have to reduce the chloride level in the pool water more than in all the other pools, because once you come back above the 800 or the 900 milligrams a liter chloride, your stainless steel is not able anymore to go for a long time for the quality you wanted.
Yeah.
So it costs a lot of fresh water.
Yeah.
And then we go back to the dilution system.
Yeah. So you have a lot of fresh water to be able to manage dealing with.
More than that on
high
this moment
conductivity.
is not possible to say. Why not? Because we have to wait a couple of months till the situation is run like it has to be.
Yeah.
And to find out on that moment where are we with the water quality and how do we get there.
Yeah. No, I understand that.
important.
No,
If
for
we
sure.
need too much fresh water to come to the situation, then I have to tell you after a couple of months' time that is not the best practice we can have for swimming pool building.
Yeah,
And
in
so-
that case, you would have to get some other treatment infrastructure that would help you to not have to use as much fresh water. But even that, like an RO system, has a lot of waste as well.
And that's what we have in the stainless steel systems. Where I know they have about two RO systems in use to get rid of the chloride and everything, the sulfates, so that it is not attacking the stainless steel.
Yeah, even though stainless steel can be kind of on the outside, like not visible to the water basin. We've seen situations where obviously groundwater or other water can come up and potentially also create corrosion problems as well.
Maybe groundwater and not controlled water is always dangerous.
Yeah, for sure. No, for sure.
If your pH is about 3.5 or 4 before the water is coming up, you can't tell me that it is not going to attack the metals of stainless steel.
Can we talk for a moment about circulation systems in a pool? I think it's very important. It makes a big difference. So what do you think, Christel? Like, what would be an optimal circulation
I think the best
system?
is the vertical system. So injection via the bottom, and then to bring it back to via the sides of the pool to a buffer, or skimmers. It's also possible.
Either skimmer or buffer.
Buffer, and then have a good filtration system in it.
Yeah, so let's go down maybe then to the mechanical room. One of the things that we often see is that the mechanical room is too small. That they, build a pool and then there's no room for equipment, and then everything is kind of,
I think what they did here is very good. That you have around the pool, you can walk around the whole pool. So
underneath.
So you have all the room around the pool is used to put in the equipment, and you have a good view, you can attach all the pipe work. You can also for service in the future. If there's a problem, you easily can all parts are.
So the footprint effectively is so the mechanical room is effectively the same footprint as what's above, but it's underneath. Yeah. So you have lots of opportunity and space to make the best use of that space.
It's the space they built is also not only a very small space. You have room. You can stand there. You can walk around.
Yeah. There's enough vertical space as well. No, I saw that. I think that makes a lot of sense because that also gives you a lot more options on having an optimal water treatment system as well.
The basement is the most important item for good water quality
in a swimming pool. And it's going to save you money in the end. Yeah. If you have it properly designed, it's going to save you money rather than trying to manage with a small little space and equipment that only fits in there.
And you have to think about the routing. So how is the equipment put in the room? Is everything? Can you reach everything? Is it easy to service? Because if a swimming pool is built for 40 years, you have to do service for 40 years. And if you have a problem with during the building, you have it for 40 years. Yeah. If you're not allowed to come in with big pumps or something like that, or you don't have a door you can reach the technical room from the inside, or you want to have access from the outside as well. Yeah. If you have to bring some chemicals inside, or if you have to bring spare parts, that's all what you have to think of.
Yeah, no, I think so too. Maybe then getting into the details, Ludo, of the mechanical room. So water quality, how is that achieved? What are the design principles?
A good filtration system is a system that has a filtration speed not more than 30 meters an hour.
Yes.
That's the start.
Okay.
The medium inside has to be sand filtration with hydroanthracite from the good type.
Yes.
Not the H but the N.
Yeah. Mm-hmm.
The filtration speed is very important.
Yeah.
Too low speed is not good, and too high is even not good. So. Anyhow, with a hydroanthracite filtration system, you cannot come above the 30 meters an hour.
Right.
Linear space. Space niet. Speed.
Speed, yeah.
Yeah, and then the biggest problem what I see in the pool of today is the cleaning regime from the walking areas around the pool.
Yes.
So first of all, I think and I have to speak with Mark about it, because I think when you have a beautiful swimming pool, but your tiles and your walking around floors are given an idea that they are never cleaned, that makes also a very different view of a swimming pool is what we see.
Yeah, you mean the impression that it gives?
It's a large pool.
Yeah.
That means that the cleaning works are not so easy.
Right. Yeah. So making sure that there's also not only is it clean, but it looks clean, and there's
It has to look clean.
It has to look clean.
If it is clean, that's maybe another item.
Yeah.
But therefore you need some bacteriological analysis, and I think they are going to do that again.
Yeah.
In there, that's not a problem.
Sure. So good filtration is absolutely critical. Obviously, it has to be properly designed, and it has to be able to do what it needs to do. Flocculation is another very important component to that kind of filtration.
It's not possible without.
So even sand filtration, you have to do it with flocculation, even if you don't have.
Sand filtration alone is not enough anymore.
Yeah, but for a pool that that's already kind of has it designed with just sand, right? So.
Okay, but you can change that then.
If it's tall enough, yes. Yeah, that's not always
sand,
the case.
Purely sand is not enough to.
So we should say that we're looking for a vertical filter that has enough bed depth.
Yeah. A filtration that about 1 meter is enough.
Yeah, no.
But the space above.
But not a horizontal filter. You are.
It's possible, but it's waste of the time, waste of the money,
and waste of space.
And waste of space.
Because you need to make it so much larger, generally speaking. Yeah. True. Okay, so what else is important? Let's talk about the pool pump, Christel.
During filtration you have a certain flow that you need to achieve. and therefore you need to select the good circulation pump. But much more important is that same circulation pump, or in combination with another pump, that there is a double speed in the backwash for that same filter.
Yeah.
And that is the most critical in a good multi-layer filtration. That they don't choose the correct pump, and that they have problems with backwash.
Because the backwash
afterwards.
is too slow and it's not actually
it's
getting
not,
good fluidization. The bed doesn't
have enough fluidization.
Yeah.
And that so the dirt stays in the filter and gives you problems.
Yeah, no, I understand that, and so they don't look at the curve properly and see what is this pump capable of doing. Yeah. Does it have the capacity for normal flow?
Yeah.
Does it have the capacity for the backwash flow?
That's very important
as well. Yeah, no, that's a good bit of information. Ludo, in different parts of the world, they use good physical filtration systems. So there's a lot of work that's gone into improving physical filtration. So low micron ratings, smaller footprints. What is your main concern with those systems, and how can we optimize or make those systems better? Let's say we work with, somebody already has a design, they've already determined they're going to have a good physical filtration system. How can we, what are some challenges with that, and how can we make that better?
Yeah, first of all those filters has no capacity to remove bacteriological urea compounds away from the water.
Right.
So the biggest problem in swimming pool.
It's okay, just leave it.
Hij is uit, hè?
Mm-hmm.
The biggest problem in the swimming pool is, of in the filtration system, is of course the urea removement of everybody is coming into the pool, release about 30 milliliters of urine.
Yeah.
And if you have 2,000 people in this pool, you have a lot of urine in it, and the only way to get rid of it is a good filtration system, like it has to be, with urea. And if you have not a sand filtration system what is able to do it, then you need a side stream filter, but it's never big enough because it's smaller than the normal circulation system. Though if you use down 20% or sometimes 30% of the water going over that small filter is not enough. It's in fact not enough to get good results in the rest of the pool. It's always too small.
It's difficult.
That's difficult. Yeah.
So would an advanced oxidation system potentially work for something like that?
Work. Without all the rest, I don't think that the advanced oxidation system can do the job only.
Yeah. Okay.
It's a good medium to put on if you want to spend the money for that.
Right.
I don't say it's necessary to have, but even, and we will see that in a couple of years' time here also, if the amount of people who are coming in for a swim is so high that the normal situation of filtration is not enough to run, then we have to think about something else.
Yeah.
But with the UV lamp they have now on this moment is not an advantage.
No, and maybe I wanted to talk about UV a little bit. So UV has a place in swimming pools, but generally speaking, stay away from the low pressure systems, the monochromatic lamps. Generally, they cause a lot of other disinfection byproducts potentially.
Yeah, a lot.
And they certainly can deal with trichloramines, but they are creating a lot of, and we have seen this, we've tested this many times. So if you're going to design a UV, in an optimal world, you would have it on a side stream and you would have a polychromatic lamp. Is that how you would use UV in a swimming pool?
If I should use UV, it's always a polychromatic lamp, never a mono.
And on a side stream?
On a side stream.
Yeah. Okay, so that you don't have to make it very large. It can be, or you can use, singular UV system for all the pools if you're going to use it for some disinfection byproduct removal as well, potentially.
No,
yeah. Okay.
That's it. Yeah.
Very good. Yeah. So let's talk about control, Gerben, and monitoring.
Mm-hmm.
Something you know something about, huh?
A little bit.
Yeah. So they obviously chose for a photometric colorimetric principle.
Yes.
Obviously for good reason. Why use that kind of a system in your design?
Because that system is the same system as you has to use for your manual readings.
Yeah.
And it's
Your digital hand meter.
The
Well,
DPD method.
Not all.
No?
Yeah, some people use,
Yeah.
titration kits
Titration
or,
kits, okay.
or semi-quantitative kits. You see that, right? So, but anyway,
I
in
mean,
a good digital hand meter, good photometric, colorimetric digital hand meter, you have an automation of that system. So it's exactly the same measurement principle.
With an amperometric system or a chemical sensor, you always have to calibrate the system with your hand meter, so your measurement is as good as your hand meter is,
right,
and as stable as your hand meter is. So
yes.
if you don't do the right calibrations or not the right frequency, then your readings are not okay.
Yeah, and that's the same with pH, of course, as well.
Yes, and your
calibration is important.
Everything,
photometric system is independent of pH, of flow or salt or other values in the pool, so it's really stable.
Very stable, and that's a challenge certainly with some of those other filtration systems potentially.
Yeah.
So you need to have that stability so you can have a consistent process control.
Yeah.
I heard today that their chlorine level is around 0.8.
Yes.
And that seems to be common in all of the different pools, which was very encouraging. Even in the 32 Celsius pool, that's what they run.
Yeah.
And they seem to be doing very well with that.
If you look in the graphs,
depending on the pH, huh?
Of course, yes.
Yeah, and if you looking on the graphs, then I don't think you see a bigger delta than plus or minus 500ths of chlorine value or pH value.
Yeah. No, it's very, very consistent, and we've seen that as well. So that's extremely helpful. And then you can also do monitoring.
Yeah.
And automate some of your monitoring,
So
which I saw again today, which is very interesting.
There was an automated monitoring system, and that's switching between the pools. So every pool is measured 4 times an hour.
Yeah.
And that gives a good idea of the water quality.
Yeah, I have a final question on that actually. Where you take your sample, your analysis for your water from your pool, the distance from where you take your sample to where you're actually...
The sample are taken directly in the pool, so there is a separate sample water pump with 2 suction inlets in the wall.
Yeah.
And they are combined, so there are special designed grids on it, so that you don't have the problem with suction.
Yeah, when you're inside the pool for any of the guests.
Yes, and
it also delivers the water quickly.
Yes, we did the test.
Because that's important, right?
In this case, the time from the point in the pool till the SPI, till your
control system
is between 1 and 2 minutes.
Okay.
And mostly about 1 minute.
And that gives you enough tight.
Yes.
Because sometimes it can be much longer.
How longer it takes, the better it is, because you're always a few minutes back on your water quality.
Right.
And if the speed is too long, you also have problems with your chlorine value of the pool, because near the pool it's for example 0.8 of 0.8 milligram, but during the travel from the pool till your automating measuring system, you have maybe 0.6. So you have a
discrepancy. Okay.
That's what you want.
Yeah, no, I can see that looked really great actually how that works, and so that gets it there quickly, and you have the capacity to be responsive and make some changes potentially if you need to, right? Yeah.
But you have to do it separately from your monitoring system.
Yeah.
2 separate systems.
2 separate systems. Mm-hmm. Your control system, monitoring are completely separate, and that makes sense. Yeah, that makes perfect sense, because one is really a gatekeeper and the other one is managing your process control tightly, as much as possible, for sure. Well, I think that's a really good overview. I know that we could go into much more detail here, but any other general observations or thoughts? Like I thought it looked great. It was beautiful to see. I think there's much good progress that's been made. That's it. So thanks, guys. As always.
Okay.
Perfect. Very fun.
Thank you.
Okay. So I hope you enjoyed that video. I hope you enjoyed this session. I want to thank our audience for joining us again. Don't forget to like and share this video, and you can listen to this episode again and many others by subscribing to our YouTube channel or connecting with us on Apple Podcasts or Spotify. If you have any questions about this episode or future episodes, please reach out to Scott and I or email us at mywatertalks@synecotech.com. We really look forward to seeing you next month.
And from Els and I, have a great rest of your day. Take care.